Okay, so for this type of problem, you don't actually even need the linear equation. You just need the slope of the line. That's all you need. All right, so, okay, so the slope of the line, m equals -2. All right, then what you want is you want to think about it for a second. And you want to say, all right, well, first of all, let's do the unreduced slope. So it's m equals 6 minus minus 2 over -1 minus 3, which is -8, +8 over -4. So it's 8 over 4. 8 over -4. And in this case, actually, yeah, actually in this case, I would make it, it doesn't really matter. But I actually, no, I would make it -8 over 4. Like that. It'll still kind of work out, but I just think I just kind of like going from, I just want to do it like this, like going down. That's my rise and that's my run. I don't want this to be my rise and this to be my run. Okay, so here's the rise, here's the run. The rise is -8 and the run is +4. Okay. Then you want to think about, this is right here, because the arrows are pointing downward. This is what's happening at time equals 0. At time is 0, we're right there, right? Okay, and the parametric equation will be like x equals blah 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 t blah blah blah, and then it'll be y equals blah 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 t blah blah blah, right? X in terms of t and y in terms of t, right? Okay, so for the x one, we could put x equals and hold on a second. Actually, let's reduce this down. So this becomes -2 over 1. Okay, which just means like instead of going down 8 over 4, you can just go like down 2 and over 1, right? -2 and then +1. Okay, so we know that why am I forgetting this? Hold on. We know that you should x. Oh, well, yeah. Got it. Oh man, I was playing it during that. I thought I had it on pause. Okay, you ready? Um, for every unit of time t, okay? For every unit of time t, x goes 1 across. Okay, but now it doesn't really do that actually, because it just maintains the same ratio, right? So for every, here, let's write this down. So for every unit of time t, x goes +1 and y goes -2. So you run 1 and you rise -2, right? But that doesn't have to be for, t could be like a millisecond or 0.25 milliseconds or 0.25 seconds. It's going to maintain the same ratio, Does that make sense? Like you're always, your slope will still maintain that 2-to-1 ratio. Okay, so now that we know that, you say, all right, well, if we're talking about x, so x goes positive 1 for every unit of time t, right? So, yeah, cool. And, okay, and the starting value, when t is 0, right? So like, when this works out to be, so we have 1 times 0. When t is 0, x is negative 1, right? All right, so then this has to be negative 1 right here. You see, because when you work out this math right here, x becomes negative 1. Yeah, so at t equals 0, x must be negative 1 according to our negative 1 comma 6, right? All right, so we have our x equation right here. There it is. Now for y, same logic. So y equals, okay, so for every same unit of time t, for every unit of time t, you run negative 2. You go down by 2. And you see how you want to have your reduced fraction because you're actually splitting them up, right? So we would actually, if I would have used this, I would have had a 4 instead of a 1. Right. Okay. And all right, so when time is 0, what is my y going to be? Yeah. So y is going to have to be positive 6. Positive 6, and you can test that because you say, all right, well, so you have negative, yeah, that's your time is 6. At time 0 it does. Bam. Yep, this is it. And then at t equals 0, y must be positive 6, right? Make sense? Okay. Now we can check it. So make your little charty chart right there. Time x, y. And you have, well, at 0, I'd like to do that one first, please. At 0, the time is 0, x is negative 1, 0, y is positive 6, and that's bueno, right? And then I'm just going to make the ending happen by thinking about it a little bit. So at what time will y be negative 2? Well, what time has to go by so that y is negative 2? So focus on this guy right here. At what does t have to be to turn all of this business into negative 2? Well, if you could do that, no. At what time t? Or you could do what you just did, by the way. I like that. Negative 2 equal, you said plug in negative 2. Negative 2 times t plus 6. Negative 8, oops, why did I do that? Minus 6 minus 6. And negative 8 equals negative 2t divided by negative 2 divided by negative 2, t equals 4. All right? So here's, I guess, the question. At what time is y equal to, what did we just say? Negative 2, right? Yes. Domain is equal to between 0 and 4, but make sure you double check it for x. So that's we did that to kind of figure out that that time needs to be 4. T is 4, T is 4, right? Plug it back in, double check it, plug it into the original. So into right here. At time is 4, I get negative 8. Negative 8 plus 6 is negative 2. That works, right? Negative 2. And then plug in negative, what did we just say? Plug in 4 to the x equation. 1 times 4 is 4. 4 minus 1 is 3. Does it end up at 3? It ends up at 3. So that's good. And then what did you say the domain is? Between 0 and 4. Whatever unit of time. I don't know. Did they give you seconds? Then it could be light years. So yeah. That's it. Yeah.